Good afternoon, everyone. My name is Vipul Gagrani, and today I want to talk about next level learning, how to leverage semantic search and generative AI in education. I lead the search and discovery team at Coursera, and Coursera is an online learning platform for course-specific study resources. At Coursera, we want to help students prepare for their coursework, help them for their exams so that they can prepare well, learn, and remember. Our mission is to help students graduate confident and prepared. When students come to Coursera and they're looking for their study resources, search is an integral part of their journey. When they type in a search query, it can be super generic, like give me documents for Bio 101 Exam 5. Or it can be super specific, like what is mitosis. But more importantly, we can classify these queries into two broad categories. The question type queries, like what is mitosis, or the non-question type queries, documents for Bio 101 Exam 5. And this is where we leverage semantic search for the natural language sentences, because that's where vector similarity can be used. There are two sources of questions that we have at Coursera. One of them are the user questions that are asked by students for the tutors to answer. The other set of questions comes from the user-generated content or the documents uploaded by the students. What we do is we extract the Q&A pairs from them, and then these are served as questions and answers. Overall, we have over 120 million documents, and so that means we have a lot of NLP pipelines trying to extract the Q&A pairs from these documents. And we have somewhere close to 350 million plus question and answer pairs. And the idea is when a user types in a question query, again, such as what is mitosis, we want to match the most similar question that we have on our website and present the answer in a step-by-step explanation to the student. And for this case, the embedding model that we decided to use, which works, and it can vary depending on use case to use case. But what we found out by testing is sentence BERT model really works well for education type queries. And that is what we do. So anytime a new question is identified, we calculate the vector embeddings, and we send it over to Pinecone on our index. Here is a simple flow diagram on trying to explain how the flow works. So when a search query comes in, the first thing we do is we want to find out the intent. Is it a question query, or if it's not a question query? Because most often than not, if it is a question query, the student is looking for an answer to get unstuck. And so once we identify it's a question query, we get results from Pinecone, a vector-based vector-based engine, and so we get the semantically matched results from Pinecone. However, another supplemental use case is, even if they have asked a question, they might want to study more about that subject. And so we present more results underneath the answer that has been provided to the student. And these are fetched from lexically matched results, which are hosted on OpenSearch. But if a query that is asked is just give me documents on Bio 101 Exam 5, the use case is slightly different. Out here, the student just wants documents that can help him or her prepare for the examination. And in that case, we just grab the results from OpenSearch, which are lexically matched results. Here's a quick demo on how the search flow or how the search page looks at Coursera. Let's say you come in here and you ask the question, what is mitosis? The first thing we know is it's a question query. And this green box at the top are the semantically similar results for that particular question that is coming from Pinecone. And of course, it's followed by more results at the bottom. This is one type of Q&A resource, which is answered by tutor. So we say over there, it has been verified by tutor, and we give you a step-by-step explanation. There are some questions which are extracted from documents, and here is an example of one of them. Let's say I'm looking for ozone filters and which form of radiation sunlight. In this case, again, the answers are coming from Pinecone, but what we have is we have put in the metadata about the actual document itself. So we are able to show from which document these Q&A pairs have been extracted. But like I said, if the intent is a non-question query, Bio 101 week 5, there is no vector similarity in here. We just want the documents. And so that's where we use lexically based similarity search, searching for those keywords on our indexes. Next, I want to give a brief overview of how did we decide to use sentence BERT instead of the other models that are present out there, and especially what we have seen in education. So our goal, I think, which is pretty much the goal for any model improvement, is to improve the map and recall values at K, which means we want a better coverage. At the same time, we do not want to dink the accuracy of it. One of the most important things in education is accuracy. So even though we have 100% coverage, it is meaningless if the answers are not accurate enough. Before we moved over to Pinecone some 2-3 years back, we had a legacy embedding model, which was Universal Sentence Encoder, more specifically UseV3, which had a 512 vector dimensionality. And when we wanted to make the switch, we compared it against one of the best pre-trained models in 2021, which was out there at that time. And it was the sentence BERT, which has a vector dimensionality of 768. And we tried to compare them by using A/B tests. So present the results from UseV3, present the results from SBERT, see which one gets more interaction, see which ones the users are liking more. And even though they were close in terms of conversion, what we really found out was SBERT, because of its higher recall, it was able to get us a better coverage. And so we could, at a lower threshold, without affecting any of the accuracy results. So using SBERT, we could really increase the coverage by 32%. And that was fundamentally why we decided to use SBERT in our case. So anytime a question query comes in, we calculate the SBERT embeddings, and then we send it over. Here was a quick chart about the performance analysis that measures the map and recall values at different 20 and 50. The first two bars, which I'm trying to highlight here, are basically UseV3. And the last three ones are SBERT on LSH and different algorithms on FACE, but just combining them FACE for easier understanding. As you can see out here, SBERT really does well in terms of map and recall, and hence our decision to use SBERT. Switching gears, now, a lot of the queries at Course Hero have a question intent. Around 45% of the queries are very specific. And when I say question query, it's mostly what I mean is natural language sentence, where you can use vector-based similarity. And so out of those 45% of the question queries, we can answer a lot of them by using our internal data that we have, that we source from the user questions and the extracted questions. We can answer around 60% of them. That still leaves a good chunk of question queries that are unanswered, around 40% of them. And that's where we use the LLMs, such as GPT 3.5 and GPT 4. However, it does increase the coverage, but there are a lot of downsides with using generative AI. As an education company, we need to make sure that the answers are highly accurate, they are factual, and they are always given as a step-by-step explanation. We don't want to be just a cheating website where you ask a question, you get the answer, and you go off. We want to help them prepare and help them graduate. And the only way you can do that if you give a step-by-step explanation, a reasoning behind your answer. And of course, tutors provide that. But the main challenge was, can Gen AI, can the LLMs provide a highly accurate answer and give a step-by-step explanation which the user understands, and it's not just an interaction of a question and an answer. So we have conducted a lot of offline experiments at Course Hero, and it's an iterative process. The more we learn, the more we adapt, and then continuously improve it. With our A/B testing framework, we do a lot of tests on changing the prompts, changing the context, passing in more context to the LLM so that it hallucinates less and it provides a highly accurate answer. And here is a quick demo on how the Gen AI answer cards look. So if you look at this, let's say I ask another question, and in this case, I do not have an internal answer. So this is an answer generated from GPT-4 model. We stream it, we show. But what you'll notice out here is all of these answer cards have a feedback loop. They have ratings on them. And this is what we use as a proxy layer to understand the accuracy of the answers. So the users, well, you put them in front of students. The students are very picky. If they don't like an answer, they will downvote it, and they will give you a very accurate reason why they have downvoted. So instead of upvotes, what is more interesting to us is to count these downvotes so that we understand the accuracy of the generated answers. We understand where is it hallucinating. So we do provide a lot of reasons, if it's incomplete, or if it's a wrong answer, if it's not a thorough explanation, which helps us classify why is it hallucinating, or what can we do to just improve that segment. There is another use case for the generative AI LLMs. Sometimes when the answer is extracted from a document, we have the answer, but we may not have a very good step-by-step explanation for it. And that is also a very good use case for GPT, because you give it the question, you give it an answer, and you ask it to provide a step-by-step explanation for this particular use case. So in this use case that I have shared, the answer is fetched from the similar question from Pinecone. However, the explanation is fresh from GPT, as it says right there, generated by AI. And together, using semantic search and generative AI, we are trying to find that perfect balance where we are giving good, high-quality answers, which we know are good basically because we own the data, and we are fetching the generative explanations from GPT so that we can supplement the answers that we already have. But just like with any other new flashy thing out there, there are definitely challenges in Gen AI, and more particularly in EdTech, because in education, we need to make sure, the fundamental thing is we need to make sure that the answers are factual and they are of high quality. And secondly, we know from a lot of papers out there that LLMs are not fully reliable. They can suffer a lot from hallucination. Here I have a couple of examples. So in the first case, if you see, the question queries are incomplete. For example, which of the following does not occur during sprint execution? As a human, we can process it very easily that, oh, this is probably an incomplete multiple choice type question. Where are my answer options? I do not have anything to go on. But LLMs do a very good job of trying to complete it and then answer it. Well, I say it's a very good job because it does complete it, but that doesn't mean the outcome is a very good job. Because when it tries to complete the question for you and then answer it, more often than not, it hallucinates and it provides wrong answers. Another one is, which of the following is not a common reason management might seek assistance from an OBM specialist? Again, the answer options are missing. So there is no point for LLM to answer it, but it will not give up. It will still try to answer it. So this is the first type where there is incomplete or partial question queries where we have seen a lot of hallucinations happen. But sometimes, even though the question seems complete in itself, just because of the model and how it has been trained, it does not give a high-quality answer. For example, if you take the first question out here, it is asking what is the provider ratio per 1,000 people population according to WHO. Even without the answer options, the question is complete in itself, and it is just a fact out there. However, the Gen AI responds that the answer is 1 provider per 1,000 population, but the correct answer out here is 2.5 providers actually. And the second example is quite funny because although the Bush administration generally maintained a hands-off approach, the president insisted that, and it says with confidence, and of course this provides an explanation for it also, it says that Iraq must be invaded to remove weapons of mass destruction, which were later found not to exist. However, the correct answer is just completely opposite. The correct answer out here is Bush administration wanted Germany to be reunited and be part of NATO. And these things happen a lot because, especially at Course Hero and in education, when a student types in a question, they want to get help and get resources to answer their homework assignment or to help prepare for their exam. And it's very bad if we do not try to stop these type of answers because now they are learning something which can be fundamentally incorrect. and which can affect their grades. They might not know it. They will trust the answer blindly. And so as an education sector, the onus is on us to make sure we give them as correct answers as possible. So when we run the A/B test, like I said, we use the rating mechanism as a proxy layer to figure out, okay, what is the accuracy of the results? And this is an interesting chart. So it is divided into GenAI explanation answer card and the GenAI answer plus explanation. So given a question and an answer, just asking it to generate an explanation, the numbers are quite remarkable, because if you see the downward for an explanation, the GPT-3.5 is at 72% compared to 31% of GPT-4, which means that as an LLM, GPT-4 does a much better job in giving accurate answers. And the second upward is also very interesting, where the thorough explanation is 43% compared to 85% for GPT-4. What that means is GPT-4, and it might not come as a shock just because GPT-4 is a larger model, we all know it is better, but this is the way of us proving it out and testing that hypothesis. So we understood that, oh yes, GPT-4 does provide very thorough explanations when it does well. That doesn't mean it doesn't do well, because a lot of the times, if you look at the downwards, incorrect answer is also at a 36%. It's lower compared to GPT-3.5 Turbo, but it's still at a very big number. However, if the questions are super easy, the ratings tend to normalize, which is evident in the second line over here at 61% and 60%. Because when students ask normal questions, which are not very hard to understand, both the models do equally well. And this is what we found out from our A/B testing as well. So GPT-3.5, it does a really good job in easy-to-follow answers, but might not do as much as GPT-4 in terms of the thoroughness of the explanation. Another interesting challenge in EdTech is, can we somehow figure out which model does well for which type of subject? And so when we ran the subject analysis, it was quite evident that GPT-4 does a very good job for STEM subjects, which are non-subjective. So these are factual answers. So when it is providing answers for, I have highlighted in bars, for subjects like chemistry, computer science, geography, maths, you can really see the blue line, the blue tower, overshadow the green tower by a lot. And in general, that's what we found. STEM subjects tend to do much better with GPT-4. And the results are comparable for non-STEM, something like history or political science, where they are comparable. GPT-3.5 does an equally good job because they are more subjective. And this is also in line with the GPT-4 benchmarking technical paper that they published. When they tried to run GPT-4 in giving exams, it really aced in AP Chemistry and GRE Quant for GPT-4. And GPT-3.5 performed better in more subjective, like the GRE Writing and AP US History. So now that we have spoken about hallucinations and how it is such a big factor, especially in education, especially at Course Hero, what does Course Hero currently do to address the hallucinations? Like I said, it is an iterative process. And as we run more and more A/B tests, we learn more, we make more and more changes. But currently, what we have found out is you can do a lot with prompt engineering. And so adding phrases like, you are an academic tutor, or instructing the models to specifically not answer if the question is nonsense, tricky, or incomplete. And based on the surface, for example, in search, if we know that based on the user history, oh, this student belongs to someone who is taking chemistry courses, and maybe he's taking chemistry and computer science, we do not want the GPT model to give answers that are outside his courses. And so we can add something like making sure you will stay within the subject bounds of whatever course they are taking. And this has helped improve the accuracy by a lot. Another thing we do is pre-processing the questions. Like we saw in the earlier slides, the search usage, we know that based on our search usage, the GPT models, they don't do well for partial questions. So why even bother sending them? And there are a lot of such use cases where a student literally copy-pastes their question, but they forget to copy part of it. And so we try our level best to figure out the answer options if, let's say, based on semantic similarity, we know that this question is possibly related, but again, we need to be confident enough. It needs to cross a certain threshold for us to confidently say that these two are the same questions. But if we cannot do that, then we just don't send these questions to GPT, and instead we give out messages to the user. Oh, did you mean something else? Do you want to try and complete your query? And other sort of prompts that can help user reframe their search query and try again. One more thing we do is post-processing the answers. And this was very interesting because if you try to just grab the answer, the models are super slow. When we try to load test it on approximately 800 requests per minute, and the P95 was around 8.8 seconds for GPT 3.5 at a 256 token limit. And so we use streaming responses, get one token at a time, which is almost instantaneous. But that still doesn't mean that we cannot intercept the streaming response. So we wait for certain tokens, we intercept the response, and we instruct the model to return with certain phrases if it's not able to answer. And based on what phrase it has returned, we then show some more intelligible and more comprehensible error message to the user, which can help user rephrase their query to get a better answer instead of GPT just spitting out garbage at them. Then another thing to improve the explanations, and this has actually worked wonders in terms of improving the accuracy, is it helps to pass the question-answer pair instead of just the question. So let's say I have an answer and I have a question. I can send the question and answer pair along with the options and then ask it to generate an explanation, which will give us a better explanation for that particular question. But we just don't stop there. And the reason, we are trying a lot of things that I've put up on the future plans. The only reason I've put that as future plans is because they are not yet on production, but they still exist in lab, and we are experimenting them. One of the important things is that has helped us stop hallucinations in an experimental level is providing more context to the GPT model. The idea here is quite simple. Match the question text with the internal Course Hero content. It may or may not have the answer, but there is still good data around that question. So semantically match that question to whatever data we have and send this as a context to GPT. So instead of just saying that, hello model, just answer what is mitosis, I can actually figure out, okay, these passages or this type of content can help it answer. So if I append that and then I try to instruct the GPT to give me an answer from that context, it has improved the accuracy by more than 4%, the answer accuracy, which is a big number, especially for the models which are already highly accurate when it does well. Then we have also tried adding different signals like the subject, the course metadata, and other fields that are related to the query that we can parse out the concepts, which can help add that as a context to reduce the risk of hallucination. One interesting thing was that we are also experimenting with is instead of just sending a question-answer pair, what if you send multiple question and answers as examples? And every use case is different. At Course Hero, we expect a step-by-step explanation and in a certain format. So if we send the question-answer pairs as context to GPT, it respects that, and it gives us an answer and explanation in the format we want. And because it is trying hard to adhere to the format we have given, that in itself reduces the risk of hallucination by a certain extent. One interesting thing in this space is providing citations. And the idea here is quite simple. You match the answer text that GPT produces to the internal Course Hero content and provide citations to students. Why is this important? Because GPT does not have confidence scores. Anytime if they see a citation that is within Course Hero and it's a Course Hero document, that in itself will help verify student the accuracy of the generated answer. And it can also help us if we are not able to generate citations from over 120 million documents that we have, which constantly increases every day, then maybe is this question an academic question, or is it just a random question that they are trying to ask Coursera? The things we are experimenting with right now is the Pinecone's plate and sparse dense vectors, which is also probably called hybrid search, and the AWS Open Search using BM25. Another future plan for which is just like a natural progression. So now you have Gen AI. What can you do after that? Oh, you put it in a chat. So extend the use case to a chat interface to allow users to ask follow-up questions. And we are experimenting with different types of chat on the surface, some open-ended, some with dynamic builds, some very particular, very prescriptive, to see what works, what the students really like. Here I have a quick demo of one of the chats on our surfaces. So in this case, these are all the courses that I have taken. Let's say I want to study more about my financial management course. I go into that. I can ask it, what are my classmates studying right now? Now this is a response generated by the GPT, but as you can see, the documents are from Course Hero. So that's how we feed it. That's how we get into citations, that these are the documents that the Course Hero students or people on this platform are actually studying. Then I can further deepen my understanding by going, can you help me understand what is supply? And what is interesting is each chat message is followed by a follow-up. So it doesn't seem like just a single interaction, but more like a chat journey where you can continue understanding, deepening your learning till you want it, till you are happy that we have provided you with the best answer. And that is it from me. Thank you, everyone.